Hello everyone, this is another video of Calculus 1. In this video, I'm going to explain trigonometric limits. Trigonometric limits. There's an important theorem which says that limit theta is any angle, goes to 0, sine of theta divided by theta is equal to 1. In limit theta goes to 0, 1 minus cosine theta over theta goes to 0. These two are very important trigonometric limits that you're going to be using over and over again to solve problems. Proving this theorem is not necessary, but it is good to know how to do that. But you will be not asked to do it um, in the future, but it is good to know how to do that. So to prove this, we're going to use a theorem called squeeze theorem. Squeeze theorem. Now, what is this squeeze theorem? The squeeze theorem says that um, if you have any function fx, right? You have a function fx, and there are two other functions, L of x and U of x, where L of x is always the values of L of x is always greater than f of x, and U of x values are less than L of x. You can I can draw that something like that. Let's say this is f of x, and then you have L of x, and then you have U of x. This one, this is sorry, this is L of x. This is f of x, and this is U of x. This is called upper function. This is lower function, and this is f of x. So these functions looks like that. I mean, it shouldn't be parallel like that I have drawn, but anyway, so the values should be always higher for the upper function. In the lower function, the value should be always lower than the values of f of x. And assume that you have x, uh, assume that you have a c in open interval ab. C is in open interval ab. And for x not equal c, x shouldn't be equal to c. And for that limit goes to c, L of x is equal to limit as x goes to c, u of x. Both lower and upper functions limit when x goes to c is L, then limit x goes to c, f of x exists. And limit x goes to c, f of is equal to L. Right? Now, if you can find two functions such that the values of u of x is always greater than of uh, greater than the values of f of x, and the values of L of x is always less than the values of f of x, and those two functions goes to the same value as x goes to c, then the limit of f of x as x goes to c is the same. You don't you might not understand this at this moment, but let's consider this example. Uh, let's consider the other theorem. So let's call that theorem 3. If we can find cosine theta, so we can find this one. Cosine theta is less than or equal to sine theta over theta less than or equal to 1. For this domain, for theta equals negative pi over 2 to pi over 2, theta is not equal to 0 within this domain. Now, by using the squeeze theorem, we can see that this cosine theta is the lower function, L theta, and sine theta over theta is our f theta, f of theta, and 1 is the upper function, upper function. Now let's see where does that lower function and upper function goes to when theta goes to 0. So limit theta goes to 0, cosine theta. When theta goes to 0, cosine theta goes to 1. When limit theta goes to 0, 1 goes to 1. So these two are equal. And what happens? Then we can prove that limit theta goes to 0, sine theta over theta equals 1 from the squeeze theorem. This is from squeeze theorem. What we did was that we used this theorem and the squeeze theorem to prove the first theorem. Now, what with the second part? The second part would be this 1 minus cosine theta over theta. Let's see how we get that one. So the second part is limit theta goes to 0, 1 minus cosine theta over theta. We might need a little bit of simplification here. So the trick is that I'm going to multiply both numerator and denominator by 1 plus cosine theta. So if I do that, limit theta goes to 0, 1 plus cosine theta times 1 minus cosine theta divided by 1 plus cosine theta times theta. Okay, so just multiplied by 1, right? So we have limit theta goes to 0. This is 1 minus cosine squared theta divided by 1 plus cosine theta theta. And you might remember a trigonometric identity, sine squared theta plus cosine squared theta is equal to 1. So in therefore we can write sine squared theta is equal to 1 minus cosine squared theta. So instead of cosine squared theta, I can put sine squared theta, limit theta goes to 0, sine squared theta divided by 1 plus cosine theta times theta. Now I can write limit theta goes to 0, sine theta over theta times sine theta divided by 1 plus cosine theta. And I can apply basic limit laws, the product law, limit theta goes to 0, sine theta over theta times limit theta goes to 0, sine theta divided by 1 plus cosine theta. Does that make sense? So this limit, we proved that this is 1. Limit sine theta, now I can use the quotient rule, right? Limit theta goes to 0, sine theta divided by limit theta goes to 0, 1 plus limit, that's the summation law, theta goes to 0, cosine theta, right? So this is 1, that is 0, right? Theta goes to 0, sine theta is 0, sine 0 is 0, this is 0, and that 1 plus this is 1. So this is 1 times 0 over 2, that means 0. That means limit theta goes to 0, 1 minus cosine theta over theta is 0. So we proved the second part of the theorem. Okay. So what we are going to do is we're going to use these two theorem, these two identities, limit theta goes to 0, sine theta over theta equal 1, and limit theta is going to 0, 1 minus cosine theta over theta equals 0 for our examples. Okay, these are the two things that we're going to use in example. Let's do an example. So example 1, limit h goes to 0, sine 4h divided by h. Now we have sine 4h, but on the denominator you have 4h. What I can do is I can multiply both numerator and denominator by 4. Limit 4 times sine 4h divided by 4h. H goes to 0. Now I can take the product rule, limit h goes to 0 4 times, limit h goes to 0, sine 4h by 4h. Now as you know, when h goes to 0, 4h also going to 0, right? Because it's 4 times multiplied by constant, 4h is equal to 0. So I can write this is just 4, and this is limit 4h. Instead of h, I can write 4h, right? 4h going to 0, sine 4h divided by 4h. So this looks familiar. That's equal to 1. 4 times 1, right, is equal to 4. So that's the answer. Does that make sense? Okay. To another example. This is from the example from the book, problem 17. The example is limit x goes to 0, tangent x over x. Now we don't have a theorem for tangent x, but we have a theorem for sine x. So what I would do is I would take limit sine x over cosine x over x, right? X goes to 0, right? So I can write this as limit x goes to 0, sine x over x times what? Limit x goes to 0, 1 over cosine x. So this part right here, this is equal to 1, right? And this is uh, cosine, when cosine uh, x goes to 0, cosine 0, right? It becomes cosine 0. This is a continuous function, so you can put cosine 0. Cosine 0 is 1, so it is multiplied by 1 divided by 1. So it's equal to 1. Okay. And problem 18. Problem 18. We have 18 from the book. The problem is limit x goes to 0, sine x secant x divided by x equal limit x goes to 0, sine x over x, right? And times limit x goes to 0, uh, secant x, right? And then this is 1, this is 1, and this can be written as x goes to 0, 1 over cosine x, right? 1 over cosine x, this goes to 1, right? So 1 times 1 over 1 equals 1. And problem, the next problem is 37. Next problem is 37. Limit uh, h goes to 0, sine 2h times sine 3h over h squared. I can divide this into two product of two functions. Limit h goes to 0, sine 2h over h times sine 3h over h. And then I can multiply this portion by 2 and the other portion by 3 like this. Limit h goes to 0, 2 times sine 2h divided by 2h, and then the next part 3 times sine 3h divided by 3h, and then we have limit h goes to 0, uh, and when h goes to 0, 2h goes to 0 and 3h goes to 0 as well, right? So I have 2 times 2h goes to 0, sine 2h over 2h times 3 times limit 3h goes to 0, sine 3h divided by 3h, right? So this portion is equal to 1 and this portion is equal to 1, right? So we have 2 times 1 times 3 times 1, right? Times, so we have 6 for that answer. And the next problem, next example is 44. we have limit h goes to 0, 1 minus cosine 2h divided by h. Uh, in this case, what we can do is we can multiply this by 2, right? Limit h goes to 0, right? Uh, 2 times 1 minus cosine 2h divided by 2h, and I can use the product law. Limit h goes to 0, 2 times limit h goes to 0, 1 minus cosine 2h divided by 2h. Now when h goes to 0, 2h also goes to 0, so I can make this 2h, right? Without any problem. And this part is 0, and this part is 2. 2 times 0 is 0. And our next problem is 46. 46. So this is how we use our theorems that the theorem that we learned in this section. Limit t goes to 0, 1 minus cosine 2t divided by sine squared 3t. So in this case, we have sine squared 3t, and we can write cosine 2t in terms of sine. Okay, in terms of sine, what we can do is we have identity uh, cosine 2t is equal to 1 minus 2 times sine squared t, right? This comes from cosine 2t is equal to cosine t plus t, right? And I can write this is what? Cosine t times cosine t minus sine t times sine t, right? And this is what? Cosine squared t minus sine squared t. But we also know that cosine squared t is equal to 1 minus sine 1 minus, sorry, 1 minus sine squared t minus sine squared t, right? So we have 1 minus 2 sine squared t, right? So that's this. This is cosine 2t is equal to 1 minus 2 sine squared t. So we can write limit t goes to 0, 1 minus 1 minus 2 sine squared t divided by sine squared 3t. Okay, so we have limit t goes to 0. This is negative 1, positive 1 cancels out, so you have 2 times sine squared t divided by sine squared 3t. Okay, all right. So then we can write we can make up this into uh, sine t over t, two terms, right? So for example, we can write limit t goes to 0, uh, 2 times sine squared t over t squared, right? Times 3t squared. So you have t squared here, sine squared 3t. Okay. Since you have extra 9, because 3 is squared, I'm going to add 3 squared here. Okay. So that cancels out to this. So we have limit t goes to 0, 2 over 3 squared times limit t goes to 0. This is what? Sine t over t squared, right? Sine squared t is sine t times sine t. That's sine squared t, okay? Times, this is limit t goes to 0, 3t over sine 3t squared, okay? And we have here is 2 over 9, and this is equal to 1. 1 squared is equal to 1 times, this is we can write when t goes to 0, 3t also going to 0, and we can write 1, sorry, limit 3t goes to 0, 1 over sine 3t over 3t squared, right? And this portion is going to 1, right? This is also 1. That's what we wrote here. And this is 1. So we have 2 over 9 times 1 times 1 divided by 1. So its answer is 2 over 9. Okay. So keep in mind that sine square t is equal to sine t times sine t, which can be written as sine t squared. Actually, sine squared t is equal to sine t squared. But it is not equal to this. Sine squared t is not equal to sine t squared. Those are two different things, but this is the same. Okay, that's an important note. Okay, with that, I conclude this lecture. If you have any questions, please let me know, and we will discuss that in the class.